Now, the first reactions we're going to study of carbonyl compounds, we're just going to give a nod to some further redox chemistry that they do. And again, we talked back in the alcohol chapter, we said, well, if you can oxidize alcohols to make carbonyl compounds, then you can reduce carbonyl compounds to make the alcohol. So we can take an aldehyde, reduce it with sodium borohydride to make a primary alcohol. We can take a ketone, reduce it via sodium borohydride to make that secondary alcohol. So aldehydes, ketones can be reduced. Already mentioned, of course, that aldehydes can be oxidized further to give the acids. Now, this is not a terribly good way to make an acid. It's much more common that you'll actually take an acid to make an aldehyde rather than the other way around. But I'm going to mention it here and sort of break a little vow, because a couple of the tests that you learned for aldehydes are based around the fact that aldehydes can be oxidized and ketones can't. So, for example, the Tollans test, the Tollans reagent, in which an aldehyde will react up with the ammonium ammoniacal silver that you get if you remember you take a silver nitrate, sodium hydroxide, add ammonia to it to make the Tollans reagent. If you have an aldehyde present, well, then that aldehyde will be oxidized to the carboxylic acid. If it's oxidized, something else is reduced. What is reduced is the silver plus, goes to silver, which creates a silver mirror if you do it properly. Very difficult to see that in the A-level lab. But anyway, the Tollans test, and I'm talking much more about all of the tests for organic groups in a module later on, but the Tollans test based around the ability of aldehydes to be further oxidized. Same deal for the Tollans test, which of course is a test for reducing sugars, whatever they might be. Essentially, it means if you've got the aldehyde group in this sugar, you mix it up with the Tollans reagent, which is essentially that blue copper 2+ solution, then the aldehyde can be oxidized, of course, to the acid, and as it's oxidized, it reduces the copper, not from copper 2 to copper 0, but from copper 2 to copper 1, that cuprous oxide, copper 1 oxide, which is that brick red precipitate that you see with the Tollans test. So redox chemistry associated with carbonyl compounds, not limited to synthesizing aldehydes and ketones from alcohols, but of course reducing aldehydes and ketones back to alcohols, and then the fact that aldehydes can be further oxidized to carboxylic acids, not an amazingly useful synthetic route to carboxylic acids, but a very nice way to do some tests for aldehydes that exclude ketones.